Let's talk about circles. So this is a circle. We know what the radius is from the center of the circle to any point on the circle, on the circumference of the circle, basically. On the, of course, the radius and the diameter have a relationship. The radius is basically one half the diameter, or you can think of the diameter as two times the radius, right? So we've talked about the area of a circle before, which is pi r squared, and the circumference is 2 pi r or pi d. So these are good formulas to know. But I want to make sure that we discuss a few other aspects of circles. Here are a few properties to keep in mind. The central angle occurs at the center and cuts the circle at an arc whose measure is equivalent to the measure of the angle. You can look at that in a typical geometry textbook. And again, in a typical geometry textbook, if we just go to the section on circles, we can look at the different aspects, the arc, the chord, the tangent. Those are good things to just see in a typical textbook setting. And we'll come back to that if we need to. But right now, I just want to focus on a few more key characteristics. The diameter is the longest chord, and it divides the circle into two semicircles, right? That's what the diameter does. The area of the sector and the length of arc. That's the area of sector and length of arc are two things I really want to focus on right now, and then we'll go from there. There is one more thing I'll mention as far as properties, and then if we need to dissect more properties, we'll make a separate video where we go into more detail on that. If you have any questions on circles, again, don't hesitate to ask. If you experience a question on a practice exam, don't hesitate to highlight it, and then we'll discuss it as well. So the area of the sector. So we know that the area of a circle is pi r squared, right? But the area of a sector is pi r squared times a measure over 360, measure of whatever the angle is. So if you have a circle and you have this measure over here and you're trying to find, like, think of a slice of pizza, right? That's like the measure of the area of a sector, right? One slice of the pizza is the area of a sector. If this angle was 30 degrees, for example, you would put 30 here and you use the formula just like you know it. If the radius is 10, you would say pi times 10 squared times 30 over 360. That's how you would find the area of the sector. Now, the formula is here. It's the same thing as the formula of a circle, pi r squared, except you do times m over 360. The length of arc, right, L is equal to 2 pi r, right? Remember your circumference of a circle is 2 pi r, but you multiply it by m over 360 as well, right? So imagine we're finding the length of arc of the same circle on the left. We would say 2 times pi times 10, 30 over 360. And then we basically solve this to the end. So you have 2 times pi times 10. So basically you can, use your arithmetic, multiply all the things together. It's the same thing as 2 times pi, or actually 2 times 10 times 30, right? I can just move the numbers side by side, times pi over 360, right? So we would get an answer there of, you have 2 times 10, which is 20, times 30, which is 600. So 600 over 360. You can simplify that. So you have 10 and you have 6, you have 5 and you have 3. So 5 over 3 pi, right? That's my length of arc. I can basically multiply the numbers together, simplify them, and I'll be good to go. See the importance of math concepts building on one another? We just had to use fraction multiplication on this problem, and that's how we got to our destination. So length of arc, area of a sector, two very important aspects of discussing properties and parts of circles. If you have a situation like this, and we're trying to find, we have a value, well, we're looking for x here, for example, say find x. Well, there's a relationship between this angle over here and over here. So basically the formula we'd be using is, we'll set that x plus 10 and we'll set it equal to half of this. And that is what we'll do. And then x will be equal to 26 in this case. And so that is 26 degrees. This whole thing would be 36 degrees. That is one aspect of circles that will be good to know. We can look at different properties if you want to dive deeper, but this is just one example of a situation here with circles. And then another example with circles is, imagine if you had this. Imagine you have a chord, and then you have the center over here, and you know that this forms an angle 90 degrees, and you know this length here is 12, for example. and I ask you to find, so let's say you don't know what that is, right? Now keep in mind this is the radius, and this over here is also the radius, right? And if you knew that this length over here, right, let's say that was 10 and this is 5 over here. So if you knew this was 5 and you know that this is 12, again, this is not drawn to scale, I'm just sketching it, then you can find what this is, right? This is your hypotenuse. So imagine you have a right triangle with 5, 12, and you don't know what this is, right? This is just an example. You can find that missing side using Pythagoras theorem, 5 squared plus 12 squared, and you will find that to be 13, right? And that's a Pythagoras triple. That's part of how I knew that. A Pythagoras triple occurs because you have things like 3, 4, 5, 3 sets of numbers that will give you the, 3 squared plus 4 squared is equal to 5 squared, or 5 squared plus 12 squared is equal to 13 squared. That's a Pythagoras triple, because 25 plus 144 will give you 169, and that's what you need to complete the problem. You know that this is 13. So if that is 13 over here, then this is also 13, because the radius is going to be 13 from the point to any part of the circle. Will always be 13. So now I know I did that quickly, but let me step back here and just quickly mention this again. We had a chord. We had this point, this line here. We didn't know what this radius was. They didn't even tell us to use the radius this way. They gave us a line somewhere off here, but we knew that if we found the radius over here, that was going to be sufficient to help us find this radius over here, right? Because it's the same radius. So it's getting us to think. I think some ACT questions are great just for practice. Even after you're done with ACT and even done with college, you could buy an ACT book and do it for fun. I think it's good mental exercise. So anyways, maybe the things I do for fun are very different from what people think, but I think it's a great way to practice and keep your brain healthy and working hard. Let me know if you have any other questions. I think that this one we've done quite a bit with circles, and if you have any questions, let us know. Have a great day.